have work. So before understanding the definition of work, let's understand the examples. Means from the example we will see in which case work is done on a body and in which case work is not done on a body. So from the previous knowledge, just tell me in which case work is done and in which case work is not done. First example we have, a person pushes a wall. As person is applying force on the wall, but in this case displacement of wall is 0, so work is not done here. Next example we have, a man is walking on the ground. As man is walking on the ground, force is applied on the ground and the man is moving in the forward direction, so here work is done. Next example we have, a man is studying. While studying, although it is a mental work, so mental work is there, but according to physics point of view, physical work is not there, so displacement is 0. So here work done is also 0. Next example we have, while eating. While eating also, this is not considered under the work of physics, so here also work is 0. Next example we have, while bicycling. Means when we apply the force on the bicycle and the bicycle moves in a forward direction, so in this case force is applied and displacement also occur. So this is the example of work done, so work is done here. Next example we have, a person is applying a force on a body and body also move, but here work done is 0. This example is little bit complicated, that also we will do in further next part in special cases, but for the time being here just see, a person here, the weight of this arrow is in the downward direction, which is a force, and the displacement occur in this direction. So although force and displacement is there, but angle between them is 90°, so that's why this work done is 0. But still this special case we will do in the next part. Next we have, a boy is applying a force on this dumbbell. So here force is applied and displacement of body is also occur, so here work is done, but here work is not done. So now let's see the definition of work. So work is said to be done only when force is applied on a body makes the body move. It means that when we apply a force on a body and body displaces, so this is actually the work done according to the physics point of view. Means we are applying the force and the body moves in the direction of force, that is called work done. So now let's derive the formula of work done with some example. So one example we have, two boys moving this roller. So as two boys moving a same roller, so they are applying the same force. So when they are applying the same force, so in this case force is same, means this is a boy, this is B boy. So force applied by A boy is equals to force applied by B boy, but the displacement of occurred by A boy, means displacement covered by A boy is more than displacement covered by B boy. Now tell me, out of A and B case, in which case this work done is more? So if you see carefully, here displacement is more. It means this boy apply more work done in order to move this ball. Although the force is same, but displacement is more in the first case, in A case. So that's why work done in A case is more than work done in B case. Now if you see the result, means if you conclude that what is the relationship between work done and displacement, so here work is directly proportional to displacement. Here S signifies displacement. Okay, now carefully see, work done is directly proportional to displacement, means more is the displacement, more is the work done. Now let's see one more example. In next example, both boy covers the same displacement. As both boy covers the same displacement, but force is different. In first case, roller size is bigger, so this boy has to apply more force. So force occurred by A boy, force applied by A boy is greater than force applied by B boy. Displacement in these cases are same. So now tell me, in which case work done is more? As this boy has to apply more force, So in this case, in A case, work done by boy is more. So work done by boy A is greater than work done by boy B. Now let's find the conclusion from this part. So more is the force, more is the work done. So work done and force are again directly proportional to each other. So now from these two formulas, make the formula work done. Work done is directly proportional to displacement, work done is directly proportional to force. So from these two equations, work done is directly proportional to force into displacement. Directly proportional sign we will convert it into equal to sign by adding a constant k. Okay, so now take k value as 1. So now here we got work done as force into displacement. So what is work done? Work done according to the measurement point of view. Measurement means in order to find the value of work done is force product of force into displacement. So now let's see the definition of force work done. So definition of work done, we have the amount of work done by a force is equal to the product of force and displacement of point of application of force in the direction of force. What is the meaning of this? Carefully see, work done formula we have force into displacement of point of application of force in the direction of force. Here for example, I have one block and I am applying a force on the block. So this point where I am applying a force, this point is called point of application. Point of application of force. When I am applying a force on this block, so the block moves in this direction. So the block starts moving in the direction of force. As the block start moving in the direction of force, so that only is a work done. Means force is in this direction and displacement occur in this direction. So product of these two values gives a work done. So definition must now it's clear that work done, amount of work done is force and displacement occur in the direction of force. This part is very important. Okay, so now let's talk about that work is a scalar quantity. What is the meaning of this? It means that work does not depend upon the direction. What is a scalar quantity? Which only depend upon the magnitude but does not depend upon the direction. It means that if you apply force in this direction and displacement occur in this direction, so you will get some work done, F into S. Now apply the same force in this direction and same displacement occur in this direction, so again you will get work done as F into S. It means that although you are changing the direction, force and displacement value is same. By changing the direction, magnitude of work done will not change. So if magnitude value of work done or any sign will not change, positive negative sign will not change, so it means that work done does not depend upon the direction. When any quantity does not depend upon the direction, that quantity is called a scalar quantity. So that's why work done is a scalar quantity.